Hello. So today we are going over inverse trig functions. We're starting a unit on inverse trig functions. And if you recall, the way we started this whole unit, I guess, on inverse functions was like coding and decoding. So like if you had a function x plus 3, you discovered that the inverse of that function was x minus 3. If you're starting with x and adding 3, subtracting 3 gets you back to where you started with. After that, we looked at logarithms and exponential functions. And you learned that logarithms were the opposite of exponential functions. And you learned how to solve exponential functions using logarithms. So today we're introducing inverse trig functions. Trig functions are sine, cosine, and tangent. Trig stands for trigonometry. And today we're going to be looking at inverse trig functions, starting with y equals the sine of x. So a few weeks ago, we were looking at circular motion, and the sine curve is one of those functions that describes circular motion really well. So we were doing a lot with it. So here is a sine curve. If you recall, the sine curve starts at 0 right here at the origin, goes up to 1, goes down to -1, goes up to 1, goes down to -1, and it does that forever. So here is 1, here is -1, and our function is entirely between -1 and +1. And there was a word that we defined when we were looking at periodic functions like this, the function's period. And a function's period is the amount of time it takes to capture one full cycle of the function. So in this case, if we look at this function, we start at the origin, we go up, we hit 1, we go down, we hit -1, and then we're back at 0. And that captures like one full peak and one full valley. So our period for the sine function was 2 pi. So I'm going to put that on this graph, 2 pi. And this spot right here was pi, and this is 0. So when our radians, so we're working in radians again, when we were looking at 0 radians, the sine of 0 radians is 0. The sine of pi over 2 radians is 1. The sine of pi radians is 0. The sine of 3 pi radians over 2 is -1. And then the sine of 2 pi radians, we're back at 0. So today we're introducing the inverse sine function. And the inverse sine function is the opposite of the sine function. So what I mean by that is, let's say I take the inverse sine function of the sine function. So just like if my function, instead of the sine of x, say my function was x plus 3. The opposite of x plus 3 is x minus 3. Same idea here. The arc sine, so it's either called the arc sine or the inverse sine. Those mean the same exact thing. The inverse sine function is the exact opposite of the sine function. So the inverse sine function of the sine function is equal to, come on, pen, why aren't you working? X. So if we take the sine function and apply the inverse sine function, we just get x. So why is that useful? Why do we want to use that? Well, a lot of the questions that we were looking at when we were dealing with periodic functions, we were asking ourselves questions about like, what is the y value when we're at pi radians? So like when x was pi radians. But what if instead of looking at it that way, we wanted to say, at what radian measure, at what value on the x-axis, do we have a y value of 1? So for example, that would look like this. The sine of x equals 1. So the way we solve for x in this case is we need to do the opposite of the sine function. And in this case, the opposite of the sine function is the sine inverse function. And we have to do it to both sides. So if we take the sine inverse of the sine function, we get x. And the sine inverse of 1, we can find either by looking at the graph of sine of x or just by knowing that the graph of sine of x has a value of 1 at pi over 2, or especially if it's a function or a value that's not as easy as 1, you can go to a scientific calculator. So this is how you calculate on a calculator the inverse sine of a value. On the Desmos scientific calculator, you have to click function, and you get more functions. So we have sine, cosine, and tangent here. We also have sine inverse, cosine inverse, and tangent inverse. So sine inverse, I can click that right there. I can type 1, and I see 90. So let me go back to my Jamboard. X is equal to 90 degrees, and which is 90 degrees is pi over 2 radians. So since we're working in radians, I'm just going to say that. X is equal to pi over 2 radians. So one interesting thing is that if we're trying to find the sine inverse of 1, you may notice that we found it right here. We used the calculator, we found it. It was at pi over 2. But look over here. There's another value of 1, of y equals 1. And there's another one over here. We just haven't graphed out that far. So when you find the sine inverse of a function or a number using your calculator, it is going to give you, I think generally, the value that's between 0 and 2 pi, or sometimes negative pi over 2 and pi over 2. So it's only giving you a value on a certain range, because there's actually an infinite number of places where the sine of x is equal to 1. So thinking back to inverse functions, we defined an inverse function. So if there are an infinite number of ways on this function, an infinite number of x values where y could be 1, do you think that this function has an inverse? So think back to how we determined if a function has an inverse, and that'll help you answer that question. Does this function have a unique value of y? No, I'm sorry, a unique value of x for every y value, or not? So when I look back through the assignment document, I think the one last thing that we need to talk about in order to help you do the exercises in the assignment document is how to solve for x. Like if you have a function involving x or the sine of x, how do you solve for that? So let's do an example. Let's say that I have the sine, let's say we have 3 times the sine of 0.4x plus 2 equals 0. So first off, we want to make sure we want to get it so that we only have the sine of 0.4x on one side. So we can subtract 2. So subtract 2, subtract 2. Now we have 3 sine of 0.4x equals negative 2. And then we can divide by 3. So divide by 3 on both sides. And we get the sine of 0.4x equals negative 2/3. So now at this point, we need to do the opposite of the sine function. So the opposite of the sine function is the inverse sine function. So let's do the inverse sine function. So let's take the inverse sine of both sides. The inverse sine of 0.4, I'm sorry, the inverse sine of the sine of 0.4x is just 0.4x. And the sine of negative 2/3, the sine inverse of negative 2/3 is negative 0.73 radians. Negative 0.73 radians. And then we can divide both sides by 0.4. So we get x is equal to, So let me calculate that. Negative 1.82. That's not right. So then, so negative 0.73. Good thing you can skip ahead when I make mistakes because I'm not recording this whole thing again. Negative 0.73 divided by 0.4. Oh no, that is right. So negative 1.825. Okay, so x is negative 1.825. So just like logarithms, there's some algebra steps here. We subtracted 2, we divided by 3, and then we ended up with just the sine of 0.4x equals negative 2/3. Then we took the inverse sine of both sides. That completely canceled out these sines. We were just left with 0.4x, and the sine inverse of negative 2/3 was negative 0.73 radians. Then we divided by 0.4 to get our answer. So I think that is all you guys will need in order to work on your assignment and the homework today. But if not, if there's anything you get stuck on, feel free to join the class meet or email me for help.